Okay, so this is the MATLAB audio DSP effects tutorial. I'm going to bring you through 5 MATLAB functions which each implement a different audio effect through array manipulation, things like that. So to do this, I need to have a sample of audio to show you how these effects affect the sound. So I'm going to use the audio read function to do that. And this takes a WAV file which is sampled at 44.1 kHz and converts it to an array of double values. All these values are between -1 and 1. So each value here corresponds to a different sample. Alright, so now to show you what it sounds like, I'll use the sound function. So it's basically just a very short clip of a clean electric guitar. Now to show you the first effect is the distortion effect, probably the most simple effect. What this does is it clips the audio, so nothing above a certain threshold is played, it is clipped to the threshold value. Similarly, if it's below the minimum threshold value, it's clipped to the minimum threshold. So to do this, to demonstrate this, I will call the function now. So I'm using the audio sample as my first argument, and then the second argument is the clip value, and I'm going to give it a value of 0.05. So anything above, any sample above 0.05 is clipped to 0.05, and any sample below -0.5 is clipped to -0.5. Now to show you the difference in sound, it should be a lot more distorted basically, similar to an overdriven guitar amp. So straight away you'll notice the difference in the sound there. Now the next effect I'll show you is the delay effect, which creates kind of a decaying echo. So I won't go into much detail in this, I'll just show you how it's called. So create a new variable called delayed, call the delay function. The first argument is the audio sample. The second argument is the feedback, so the original audio, the current audio as it's going through this loop here is added to a sample which was a number of samples ago. So the feedback argument basically gives the prominence of how much the delayed sample will affect the output. So I'm going to give it 0.4, so it decays a little bit more. Now the delay time specifies the delay value. So let's say we're going through this loop here, the current sample in a loop will be added to the sample that was played 200 milliseconds ago. In this function here, it's converted to samples, and then the next argument is just the sampling frequency. So I'll just show you the difference in sound there. It should be just a decaying echo. So straight away you can notice that difference there. Now the next function I'm going to show you is the flanger effect. So this has a similar structure to the delay effect, except the delay value is a variable delay, and the delay varies in accordance to reference sine frequency, which gives a kind of a sweeping effect to the sound. So I'm just going to call the flanger effect by creating a new variable again. Now this clip argument is just the audio sample again. This second argument here, the sweeping frequency, corresponds to that reference sine wave that I was mentioning there a second ago, so I'm going to give it a frequency of 0.5 Hz. Now the sweeping range means that the variable delay will never go above 12 samples, so the variable delay basically goes from 0 samples to 12 samples. And now the next variable is just sampling frequency again. And I'll show you the difference in sound here. It should be kind of a swoosh effect. There we go. Now the next effect is the tremolo effect. So similar to the flanger effect again, tremolo references a sine wave, but in this case the sine wave varies the amplitude of the waveform. So it's basically amplitude modulation. So to call this effect, I'm going to create a new variable, call it a function. First argument again is the sound clip, and the frequency is the reference sine frequency for the amplitude modulation. So I'll give it a frequency of 4 Hz, and then the next argument again is the sampling frequency. And now to show you the effect that has on the sound, I'll play it back. So it's kind of an underwater effect almost. Now the last effect is the low pass filter. So by default this is it's an FIR filter, and it's given a default order of 15. This could be put in as an argument here, but just for simplicity I didn't bother. Now to show you how to call this effect, create a new variable, call the function, bring in the original audio effect again, the audio clip again. Now the next argument is the cutoff frequency. So theoretically no frequencies in the spectrum of this audio above this cutoff should appear in the output. So I'm going to give it a cutoff frequency of 500 Hz. And again, just for calculation purposes, you need the sampling frequency. So this effect, as nothing above 500 Hz should be let through in the output. It should give kind of a muffled effect because it's only let the lower frequencies through. So there you go, that's clearly more muffled than the original audio. Now just one last thing, I'll show you adding two effects together basically. So I'm going to use the output of the distortion effect we did first and add a delay effect to it. So it kind of gives a chain of the two effects. So to do this I'm going to call the same arguments as before, except I'm going to use the distorted array we created, the distorted output. So now you should hear a combination of both a distorted version of the original with a delay added to it.